Hello and welcome to G Fun Facts Online, the podcast where we explore the most amazing tidbits our world has to offer. Today, we're diving into a realm where nature's genius meets cutting-edge technology. Imagine robots that can cling to walls like a gecko or grasp delicate objects with the gentleness of a human hand. Sounds like science fiction? Well, it's fast becoming reality, thanks to scientists looking directly at Mother Nature for inspiration. At the heart of this revolution is the challenge of gripping and adhesion. How can robots securely hold on to things, especially on different surfaces, or with objects of varying shapes and fragility? Nature, of course, has had millions of years to perfect these mechanisms, and roboticists are taking copious notes. One of the star players in this field is something called electroadhesion. Picture this. You want a robot to stick to a surface, any surface, smooth glass, rough concrete, even in dusty environments or the vacuum of space. Electroadhesion, or EA, makes this possible. It's an electrically controllable, sticky solution. When a high voltage is applied across special pads on the robot, it creates an electrostatic force, like a super-powered magnet, pulling the robot towards the surface. It's incredibly versatile. So what makes electroadhesion so cool? Well, first, its adaptability. As I said, it works on almost any material. Second, it's surprisingly energy efficient, typically needing only a little power to maintain its grip. Third, these systems are often lightweight and don't need bulky pumps or motors, like some other adhesion methods. And maybe the best part? The grip is controllable. Want it stickier? Adjust the voltage. Want to let go? Just switch off the power. Simple, yet effective. But scientists aren't stopping there. They're constantly pushing the boundaries of electroadhesion. They're experimenting with new materials to make the adhesion stronger and work better in different temperatures or humidity. For example, a material called PVDF is being explored to make the systems even more energy efficient. They're also getting creative with designs. Think origami-inspired sticky pads that can fold and conform to curved surfaces, increasing the contact area and therefore the grip. There's even something called paper mechatronics, using inkjet-printed electrodes on paper for low-cost, eco-friendly solutions. One tricky bit with electroadhesion has been letting go quickly. Sometimes, a residual charge can make the gripper a bit too clingy. Researchers are studying how different materials affect this de-electroadhesion time, looking at factors like how well they hold a charge and their surface roughness. The goal is to make robots that can pick things up and put them down super fast, which is vital for things like assembly lines or speedy climbing robots. And electroadhesion is a perfect partner for the growing field of soft robotics. Imagine grippers made from flexible, squishy materials that can gently mold around any object. Add electroadhesion to these soft grippers, and you've got a system that can handle even the most delicate or oddly shaped items with ease. But electroadhesion, as amazing as it is just one page in nature's grand design book. Scientists are drawing inspiration from an incredible array of living things. Take the gecko, for instance. Those little lizards can scurry up walls and across ceilings thanks to millions of microscopic hair-like structures on their toes that use tiny intermolecular forces, van der Waals forces, to stick. Robots are now being equipped with similar gecko-inspired adhesives, allowing them to make high-strength grasps. Then there's the octopus and squid. Their tentacles, often lined with powerful suckers, are marvels of flexibility and gripping power. Researchers are developing soft, tentacle-like grippers, some with multiple air-powered filaments that can achieve complex motions and securely grasp objects, even underwater. And what about the ultimate natural gripper, the human hand? Its incredible dexterity, with all its joints and an amazing sense of touch, is a constant source of inspiration. Scientists are building soft, human-like robotic hands that aim to replicate this ability for precise manipulation. Even plants have lessons to teach. The way plant tendrils curl and wrap around supports is being mimicked in flexible robotic grippers. Imagine a robot arm that gently twines around an object to pick it up. The list goes on. Crabs with their multi-jointed claws, monkeys with their palm-gripping techniques for swinging through trees. Even sea anemones have inspired unique gripper designs. So, what's making all this possible? Several key technologies are driving this progress. Soft robotics, using compliant, flexible materials, is a huge trend. This makes robots safer to work around and more adaptable. Advances in materials science are giving us new soft, stretchable, and even smart materials. Of course, these grippers need to sense what they're doing, so integrating sensors for touch, position, and vision is vital for them to adapt and learn. And powering these grippers involves diverse methods, from air pressure to special alloys that change shape with heat to materials that deform with an electric field. Often, the best solutions come from combining different technologies, like mixing soft and rigid parts, or using multiple types of sensors. And increasingly, artificial intelligence and machine learning are being used to teach these complex grippers how to grasp and handle all sorts of objects safely and efficiently. So, where will we see these nature-inspired robotic marvels? The applications are vast. In manufacturing, they can handle delicate components or perform rapid pick-and-place tasks. In agriculture, picture robots gently harvesting fruits and mushrooms without bruising them. In healthcare, they could lead to more advanced surgical robots or prosthetic limbs that adapt to the user's body. In warehouses, they could sort and handle a wide variety of packages. And for exploration, imagine climbing robots inspecting wind turbines or pipelines, or underwater robots exploring the deep sea. The future looks incredibly exciting. We're moving towards robots that are more autonomous, more adaptable, and more energy efficient, capable of performing complex tasks with a dexterity and gentleness that truly rivals nature. By continuing to learn from the biological world, we're unlocking a new era of robotics. That's all the time we have for today on Fun Facts Online. It's truly amazing to see how nature's ingenuity is shaping our technological future. Join us next time for more fascinating facts. Thanks for listening.